Hello children, how are you all? Hope you all are fine and doing well. My name is Naresh. Welcome to our channel Physics Plaza. Children, in a previous session, we have solved numericals based on kinetic energy, potential energy, linear momentum and work energy theorem. Today's session, we are going to discuss a very simple and very important topic is law of conservation of energy. And after that, we will discuss a theoretical verification of conservation of mechanical energy. And then we will discuss the application of mechanical energy also we will discuss. What is actual energy, dear children? It is a capacity, ability to do the work. It can be any form. It can be any form actually. Means what actually conservation of energy says is that. So before that, just let us think logically. Sometimes what will happen, we will take a matchstick. Then just we will try to strike against that matchbox. Then what happens? We will get a fire. I mean, we'll get some part of light, we'll get some part of heat also we'll get. From where we are getting that head of that matchstick has chemical energy. Then what is happening? That chemical energy is getting converted into heat energy and even some light energy also. So this is what actually law of conservation of energy says. So it says that we are not going to create any energy actually. It's very at the same time we cannot destroy any energy also. But what we can do? Just we are the mediators, I can say that. Just we are the mediators, we can change from one form of energy to another form of energy. This is what actually a sole concept of law of conservation of energy. So, according to law of conservation of energy, energy neither created nor destroyed, but it can be changed from one form to another form. This is what actually law of conservation of energy. Now let us see few examples here, children. So here you might be knowing about a motor, electric motor. Generally, what is the purpose of electric motor actually? For example, if you want to take a water from ground, like a ground floor to like a 5th floor or 6th floors, just will switch on the electric motor. But don't you think that it is doing some work to send water from ground floor to top floor? Of course it is sending. Means there is a change in height. There is a change in height as it is doing work. What type of work is it? It's a mechanical work. So it has a mechanical energy here. It has a mechanical energy. But from where it is getting mechanical energy? How is it able to do that mechanical energy? Because we are turning on the switch, means we are giving electricity. So electric motor is converting, in electric motor, electrical energy is converting into mechanical energy. That is fine. Then what about dynamo? It's a versus, means quite opposite. Children, in electric motor, what is happening? Electrical energy changes into mechanical energy. Then what about here dynamo? In dynamo it is a quite reverse, quite opposite to the electric motor. So what happens? That whatever the mechanical work is done, whatever the mechanical energy is done, so gets converted into electrical energy. Is quite opposite. Now look at here, loudspeaker, dear children, loudspeaker. Even just in what we can say loudspeaker, you can observe in meetings, even in parties, anywhere you can observe. So then what is happening is that here is a loudspeaker, dear children. Generally, we are able to hear sound from here. Big sounds we are able to hear. But how? From where we are getting? From where we are getting? So here, whatever the electric pulses which are given, electric signals are given here. So they are converted into sound here. Means it is able to convert electrical energy into sound energy, Then what about here microphone, dear children? So then we will be talking, hello, mic testing, all these things, whenever there is a meeting, there is a party, as I told you that, we need that mic actually to announce, to talk, to sing a song sometime also, we need that actually. So then what will happen, what will be there, there a microphone will be there, which converts our sound energy, that is sound pulses into electrical pulses. Now come to the lighted candle during birthday parties. Now we can see that during birthday parties, what happens? So just many candles are blown actually. Their candle is made, the chemical, completely chemical. So when you can light it, what is happening? That is burning and giving you some light, some heat. Some light and of course some smoke. That is also chemical, gas when it is. So here what is happening? That lighted candle we can see that, especially of course some part heat that will be there, but mainly we can see that it is a chemical energy to light energy, we can say that, light energy. So, during photosynthesis, dear children, photosynthesis, what is happening? Dear children, without photosynthesis, can we imagine our lives? Of course, no, we cannot, because we are getting a food because of actual photosynthesis. In fact, we must be very, very thankful to trees. That's what we should save the trees, save our life. It's very, very important. So here, the plants, what they are doing, dear children, they will take the light energy. They will take a light energy from the sun. Of course, whatever the light is coming from the sun, they will take, so that a food is prepared. A food is what? Carbohydrates. It's a chemical it is. So, in photosynthesis, what is happening? Light energy is getting converted into chemical energy. Okay, children? Fine. And look at here, electric iron. Yes. So, whenever we want to go to parties here, we want to go to attend any functions and all this, you know, we need a nice cloth, that too getting iron. So, we will get iron. So, actually, dear children, what is that actual electric iron? It's a completely resistor. So, when electric current passes through it, what happens, you know, gets converted into heat energy. So, electric iron converts electrical energy into heat energy, and it is versus with what actually? Thermocouple. Dear children, regarding thermocouple, we will be having a special session. There we will be learning what actually thermocouple and its effects, and how can we make, what are the some phenomena related to that, everything we will discuss. So, thermocouple, what you have to remember, a thermocouple is a device where heat energy gets converted into electrical energy. Okay, fine. Now, lighted electric bulb. Now, you all can see here, just here is completely lighted electric bulb only, where what is happening here, complete electricity is given to that electric bulb, so that what happens, it gets converted into light energy. Of course, some part even gets converted into heat energy also. Let us neglect that some part, because mainly what the purpose of electric bulb is actually to convert electrical energy into light energy only. And here, what about photocell, dear children? It's very, very, very important. Solar panels and photocells, you know, these all are nowadays, we are able to generate electricity, dear children. It's like, because if you go on using the, electricity, if you go on producing the electricity with the help of that coal, and so because some other reasons, you know, there is a problem to the pollution. But here, pollution free. So, pollution free and free also, pollution free and free. Solar energy, utilizing the solar energy. So, we will keep solar panels, where what happens, complete light energy gets converted into electrical energy. Light energy gets converted into electrical energy. And one more very important thing is that, this is very, very, very important. This is completely, nowadays, we all are depending on cell. We all means mobile depends on cell. Children, can you imagine our life nowadays? Can you imagine our life without cell? Of course, we cannot imagine, because cell has become a part. It's like it has become like one of the important organs in our body. Without cell, oh my God, persons may forget many things when they are going outside. But mobile, nowadays they are not checking whether their family members are there or not whenever they are going out, or else when they are coming, when they go to party, when they are coming back to house, they are not checking whether everybody is there, is anybody missing. No, it's not that. We are checking first mobile phone. Mobile phone is there, thank God, everything is like that. Of course, complete world is there. We are operating, we are communicating everything with the mobile only. So, such a mobile in that, so we cannot imagine such a mobile when it is in use. Then what is happening, as we are using, instead of battery will be there. There what is happening, chemical energy is getting converted into electrical energy actually. With that only a phone is operated and we are using it. But whereas during charging, can we talk with the phone continuously hours? Of course, if you can use 7000 mAh battery, you may get a 3 days, 4 days. But still after that, it will get discharged. Then in order to use that mobile, again you have to charge it. So during charging, what will happen, dear children? During charging, that whatever the electrical energy which you are giving to that gets converted into chemical energy. Children, these are the few examples. To say, to talk about law of conservation of energy. I repeat once again. Children, in motor, electrical energy converts into mechanical energy. Whereas in dynamo, mechanical energy into electrical energy. And loudspeaker, electrical energy into sound energy. Microphone, sound energy to electrical energy. And a lighted candle, chemical energy to light energy. Photosynthesis, light energy to chemical energy. Electric iron, electrical energy to heat energy. Thermopile, heat energy to electrical energy. The lighted electric bulb, electrical energy to light energy. Photocell, light energy to electrical energy. And come to the cell in use, chemical energy to electrical energy. Charging a cell, electrical energy to cell. Electrical energy to what? Yeah. Cell in use, cell in use, chemical energy to electrical energy. Charging a cell, electric energy to chemical energy. So these are the few examples. The children, even we can. Children, now we will see how to verify law of conservation of mechanical energy theoretically. Children, in a previous session we discussed about mechanical energy. So it is nothing but the sum total of kinetic and potential energy. Children, let us take in a situation where there is an interchange between only potential and kinetic energies. Then mechanical energy remains constant. That now we are going to prove. How can we we are going to study the theoretical verification of the mechanical energy. Theoretical verification of the law of conservation of mechanical energy. Means we are going to prove at every point mechanical energy remains constant. Children, in order to verify this law of conservation of mechanical energy, we can take two cases, very simple here. You can take a body is projected vertically upwards, or else you can take even freely falling body also you can take. Children, now let us imagine. So here is a ball of mass m and it is at a certain height. It is placed at a certain height now. Look at here. It is placed at a certain height. So due to change in its position, what happens? This body has only potential energy. Why? There is no velocity. Now when the body is left, what is happening? Slowly it is falling. Children, as it is going towards the earth, children, its height decreases. At the same time, its velocity keeps on increasing. Means what? As its height is decreasing, children, its potential energy decreases. But simultaneously, as its velocity is increasing, its kinetic energy increases. Means if one energy is decreasing, another energy is increasing. Of course, it is an interchange between potential and kinetic energy. But here you can take at any point you can take the sum total, the total of potential and kinetic energy always remains constant. This is what actually we are going to prove. So look at here. Children, here we considered any object, or let us say the ball only is considered. Its mass is how much? M. The mass of this ball is M. And it is falling from a height of h, means above the ground. It is held at a certain height h, so that it is about to fall. Children, throughout this journey, you can take any point. To prove law of conservation of mechanical energy. But here I considered 3 points. One is at a point A, one point B, one point C. We have taken. Means this point B, dear children, it may not be its midpoint. Any point you can take. Now let us see. Let us calculate what is the mechanical energy at point A, what is the mechanical energy point B, what is the mechanical energy point C. So before going to that, dear children, what is the velocity at a point A? Of course, it's about to fall. It's about to start its journey. Means what? Its velocity is 0. Children, as its velocity is 0, do you think that it has a kinetic energy? No chance at all, because kinetic energy is due to the motion. As there is a motion, there is a kinetic energy. As there is no motion, there is no kinetic energy. So here, as there is no velocity, let us take at a point A. Children, look at here. At point A. Now let us discuss what is the energy possessed by the body at a point A. Children, at a point A, as the velocity is 0, obviously kinetic energy will be 0. then it has only height, so due to which it possesses potential energy. So its potential energy is equal to mgh. Then what is the mechanical energy at a point A? Children, we know that mechanical energy. Children, kinetic energy will represent with a capital K, potential energy will represent with a capital U. Then mechanical energy will represent with actual capital E. So or else we can write like this: mechanical energy is equal to, we know that it's sum total of kinetic and potential energy. Then kinetic energy is 0 and potential energy is mgh. So now mechanical energy at a point A, let me write, at a point A is equal to how much? It is mgh. Means, dear children, at a point A, the mechanical energy is in the form of complete potential energy only. So this is what actually we got. Now in order to prove law of conservation of mechanical energy, means at every point we have to show that mechanical energy is mgh only. So now this is how we calculated mechanical energy at a point A. Children, now we'll see what is a mechanical energy. We will try to calculate what is the mechanical energy at a point B. But look at here, dear children, when the ball is at point A, it does not have velocity. Okay, fine. But when the body has reached already point B, do you think that still it is at rest? No, it is not that. Let us think here. It is a point A. Here it is. Now it is left. It is going. Its velocity is increasing. Means, for example, this bottle is a point B. Let us say point B, and it is falling like here. So as it is crossing this point B, it is crossing this point B, it has a certain velocity. So as it has certain velocity means what? It has some kinetic energy. So it has some kinetic energy, no doubt. And it is also at a certain height. So it has a kinetic energy and as well as potential energy also. So what we have to do? We have to calculate the potential energy of the ball and kinetic energy of the ball. Then we have to add. Then we will get mechanical energy. Children, at a point B, let us say the velocity of the ball is v1. For suppose just v1, let us say. Velocity of the ball is v1. So if the speed of the ball, velocity of the ball is a v1, then what is the kinetic energy? So the kinetic energy formula is half mv square. Half mv square means here v1 square I can say. But if you want to calculate the kinetic energy, dear children, this v1 is an unknown quantity that to be calculated. How? Here only again we are going to use the concept of equation of motion. So look at here. The ball is coming from point A, right? It is point A to point B. It is point A to point B. Children, what is the velocity at a point A? Its initial velocity is 0. Fine. At a point B, let us take only from point A to point B only, because we are interested to calculate a point B. Okay. So here the final velocity is how much here? We assume it as a v1. So what is the distance travelled? X. So here the distance travelled s is equal to x. Now let us use v square minus u square is equal to 2as. Children, as a body is travelling under the gravity, then acceleration is replaced by acceleration due to gravity. A is equal to g. But should we take plus or minus? We should take plus. Why? The body is moving in the direction of gravitational force only. So you can take A is equal to g only. Now you can substitute the data whatever we got in this. So V is equal to, it is V1 square minus 0 square is equal to 2gx. So from this it is V1 square is equal to 2gx. So children, it is equation 1 and here is equation 2. Now substitute equation 2 in equation 1. So substitute 2 in 1. So what do we get here? Kinetic energy is equal to half into m into, children, in the place of V1 square we are going to substitute 2gx, that is 2gx. Children, 2 gets cancelled. So the kinetic energy at a point B is how much? Mgx we got. mgx we got. Now we need to calculate the potential energy also. Children, potential energy is equal to what? It is mg. But what about height? Can we take h? No, we cannot take here, because you look at here at a point B. This point B, at a point B, the ball is at a height of this much. So how to calculate? This is a total height and x distance is covered. So subtract x from h. You will get that remaining height, that is h minus x. So here mg into h minus x. So this is what actually potential energy which we got. Now we have to add these two to calculate the mechanical energy. So here mechanical energy is equal to, children, potential energy plus kinetic energy, right? Potential energy is how? Mg of h minus x. We can multiply this. So we will get mgh minus mg of x minus mgx. Children, this is complete. This is what actually how I wrote. Now plus mgx plus mgx. So here mgx gets cancelled. Then the mechanical energy at a point B is how much, dear children? We got it as a mgh. So here also we got mgh only. Children, what is the mechanical energy at a point A? At a point A, the mechanical energy is mgh only. Whereas at a point B also, how much did we get? mgh only. Now we will calculate the mechanical energy at a point C. Children, look at here. Let us take a whole journey. I can take, here is point A. From here it is starting. It is coming and it's coming and it is going to hit. Let us say it's a point C. It's point C. It's a point A. It's point A. Children, what is the initial velocity at this point? It is u is equal to 0. Children, after hitting, just you forget, but before going to hit, as I told you that, children, if any object is falling under the gravity, as its height keeps on decreasing, its velocity keeps on increasing. So it is about to hit the ground. It's before going to hit the ground, just before. Children, it is not hitting the ground, just before hitting the ground. Of course, after hitting the ground, what happens? Of course, it gets converted into some sound energy, heat energy. That is different. But just before going to hit the ground, it has a maximum velocity. So let us say the velocity at a point C. Children, at a point C, just before going to reach. Here the velocity, let us say it is a v. So v is a velocity of the body, final velocity. And what is the distance traveled during this journey? H. So here distance traveled is h. And as the body is moving in the direction of gravity, we can take A is equal to G. So now what we have to calculate? We have to, at a point C, we need to calculate what is the potential energy and what is the kinetic energy. Now let us calculate first kinetic energy, children. Children, we know that kinetic energy is equal to half mv square. But again, v value is not known. To calculate, to find the v value, we are going to use v square minus u square is equal to 2as. So that is v square minus u square is equal to 2as. V is equal to, here v only we have, that is, let us substitute v only, v square minus u is equal to how much, dear children? U is 0 because it is falling. Initially it is at rest only. So it's a 0 square is equal to 2. So A is what, dear children? A is G and S is H. So it is 2GH. So here we got v square is equal to 2GH. V square is equal to 2GH. Now v square form value you can substitute in this. V square you can substitute. Then we get kinetic energy is equal to half m into 2GH. Children, here 2 gets cancelled. Then kinetic energy is equal to what? It is mgh. Kinetic energy is equal to, we got mgh. Then what is the potential energy? Children, potential energy is about to reach ground, almost it's about to hit the ground, means here h is almost 0, it's negligible. As h is negligible, as h is 0, obviously there is no potential energy. So at a point C, as the height is 0, so the potential will be 0 only. Now let us see mechanical energy at a point C. At a point C will be mgh plus 0 is how much? It is mgh only. mgh only. So children, at a point A, what is the mechanical energy? mgh only we got. At a point B, mgh only we got. At a point C, mechanical energy is mgh only. So at every point, the mechanical energy is a constant. Means it is a conserved. This is what actually law of conservation of mechanical energy. But strictly, dear children, here there is an interchange between potential and kinetic energy only, and there is no loss of energy to the surroundings or atmosphere. And one more thing, dear children, here air friction is neglected. When air friction is neglected, then only we can prove this. Otherwise, we cannot, because if air friction is present, so there will be some dissipation of energy. Definitely there will be dissipation of energy. So children, means one thing you have to understand, at a point A, the mechanical energy is only due to the potential energy. But whereas at a point B, mechanical energy is due to the potential energy and as well as kinetic energy. Means between any point, like a starting and ending point, between any point you can take any point, it has some potential energy and as well as some kinetic energy. Whereas at a point C, mechanical energy is only due to the kinetic energy. Only due to the kinetic energy. Children, this is how we can. Children, now we will see how kinetic energy and potential energy change. Means how can we represent the kinetic energy and potential energy with the help of graph. Let us see. Before going to that, dear children, just once again let us recall, as I just said, and you can see even on the screen also the diagram. When the ball is at a point A, it has only potential energy. The mechanical energy is only due to the potential energy. But whereas as the ball is reaching the ground, its height is decreasing, due to which potential energy is decreasing, and simultaneously its velocity keeps on increasing. So its kinetic energy increases. So you have to remember, at the highest point it has a maximum potential energy, zero kinetic energy. Whereas at the lowest point, at a point C, it has only kinetic energy. Then what about B? Means between A and C, dear children, it has potential and as well as kinetic energy. But let us assume that we are taking B at midpoint, exactly midpoint. Exactly midpoint means what? Exactly at a h/2 height from the ground. So at a h/2 height from the ground means exactly at the midpoint, it has 50% potential energy, 50% kinetic energy. Total should be 100%. Let me give you one example. At a point A, dear children, at a point A, the potential energy is 100 joules, example, and the kinetic energy is, let us say, 0. So total mechanical energy will be how much? 100 plus 0, it is 100 only. It is 100 only. At a point B, as it is like midpoint, exactly at h/2 it is. It is h/2. Its potential energy will be 50 joule and the kinetic energy will be 50 joules. Again, total will be 50 plus 50. Again, it is 100 joule only. Again, it is 100 joule only. Whereas at a point C, so at a point C means what? Almost height is 0. It is at a height is h. Here potential energy will be 0, but whereas kinetic energy will be 100 joule. 100 joule. So this is a case which we are taking. Now let us see. So this is what actually, how can we represent with a graph? So how it is varying with the height? Let us check once. Children, as I said that, just it is shown in the figure also given. At a point A, kinetic energy is 0. At a maximum height, potential energy is mgh, let us say. So the total will be how much here? 0 plus mgh. So total energy will be, again, total mechanical energy is, again, it is mgh only. It is at a point B, means exactly at a h/2 height from the ground. So that is mgh/2. Again, total will be mgh only. Where at a point C, it is at 0 height. 0 means almost negligible the height is. There it has only potential energy, only kinetic energy, and potential is 0. So look at here, dear children. Here height is taken on x-axis. Let us remember that here, as height is a independent quantity here. Means energy is depending on the height actually. So it should be taken on x-axis, and here energy is taken on y-axis. Now look at here, dear children. At a point C, don't get confused here. It is not a point C. A, B, C. So we are coming from A to B to C, or else you can see at a point C what will happen. At a point C, children, look at here at a point C. At a point C, if you can look at what energy does the body have at a point C. So it has maximum kinetic energy, potential is 0. So first let us concentrate only on the kinetic energy, at a kinetic energy only. So at a point C, the kinetic energy, it has maximum kinetic energy. It is how much? mgh it has. mgh it has. Okay. As C to A means what, children? C to just A, look at here. C to A, height is increasing. C to A, as height is increasing, velocity keeps on decreasing. As velocity keeps on decreasing, kinetic energy keeps on decreasing. So as height is increasing, look at here from C to A, as height is increasing. So here kinetic energy graph, kinetic energy line, it is a red color we have represented the red color. So that is decreasing, it is decreasing. At a maximum height point A, what is energy? 0. Kinetic energy is 0. Right on, kinetic energy is very important, very important. So means very much important. Whereas from C to A, let us concentrate on the potential energy now. From C to A, dear children, C to A, look at in the diagram. From C to A, actually, what is happening? Height is increasing. As height keeps on increasing, dear children, the potential energy also keeps on increasing. So this the line shown with the black color indicate potential energy, change in potential energy. Look at here. So as C to A, as height is increasing, so potential energy also increases. Potential energy also increases. At a point A, let us say exactly at point A. At point A, here it will be. So it has maximum potential energy. At a point A, it should be like this exactly. So at a point A, so you can look at here, the line is taking a maximum value at this point. Is how much actually? mgh. But what about midpoint? At a height h by 2, at a height h by 2, look at here, these two lines are coinciding. These two lines are coinciding at this point. Means at this point, it has a potential energy mgh by 2 and the kinetic energy also mgh by 2 only. But again, what is the total here? mgh by 2, mgh by 2. It is mgh only. So children, even we can explain this what a concept by taking an object which is thrown vertical upwards also. It is the same. It is same. Whether you can throw the body vertical upwards, whether you can leave the body from top. So you will get the same result. Again, I repeat it, children. So if there is a change in the energy, like interchange energy between only potential and kinetic energy, so definitely at any point the sum total, that is the mechanical energy, remains always constant. But the condition is that here we are neglecting the air resistance. We are neglecting the air. That's very important. If we will consider the air resistance, that will be again, it is a different actually. Okay, children. So when air resistance is negligible, then only law of conservation of mechanical energy holds good. Children, now we will see the application of law of conservation of energy. So this we can well understood with the help of actually the simple pendulum. The best example, dear children, as a simple pendulum is not available, hey, I am not going to do any skipping or something like that. Don't think like that. So let us just imagine, dear children, here is, let us just assume that it is a simple pendulum and it is a bob of the simple pendulum. Okay. Now it is at main position. I consider the rest position. It is at a rest position. Now what happens when it is displaced like a side? Then what will happen? It start making oscillations. It start making oscillations. So here left side and the right side, it will go maximum displacement. And here we have to notice one important point. As it is at a rest position, almost its height, means let us think about the bob, almost its height is negligible here. Almost its height is negligible. Whereas when it is swinging during its oscillations, left side and right side, maximum it is going, means as it is going left side, slowly it is raising. As it is raising slowly, dear children, due to the height, there will be some potential energy. Even this side also, for me it is the right side. So as it is like a rising right side, rising. What happens? As its height is increasing, its potential energy increases. But don't you think that during its motion, it crosses the midpoint with a maximum velocity. Here it has a maximum, as it is crossing this point A, it has a maximum velocity, but as it is moving towards the point B, what happens? Its height keeps on increasing, but due to the gravitational force, so gravity will try to pull the bob towards the mean position, So what happens? So here, as it is going towards point A, its speed keeps on decreasing, So what here? So very important. At a mean position, dear children, as it is crossing with a maximum velocity and its height is almost negligible. So at this point I can say, as height is almost negligible, so its potential energy will be 0 at this point. But whereas it has a maximum velocity V, it has a maximum velocity, children. So due to which what will happen? It has a maximum kinetic energy. Try to understand. Then what about point B and point C? So this point, let us say bob here, it is at a height h. And here also it is height h. And dear children, try to understand, at a point B and a point C, extreme points, almost as I said that, as it is moving towards point B, so its velocity keeps on decreasing, but at extreme points, for a while, its velocity will become 0. So here, its velocity will become 0. So what is kinetic energy then? Its kinetic energy also will be 0 only. But what about at point C? Same thing happens. At a point C also, as the velocity is 0, obviously kinetic energy will be 0. Means here you should notice one important point. At a point B and C, kinetic energy is 0, but potential energy is there only. So the mechanical energy is only due to the potential energy only. So children, so as this bob of mass, let us say mass is m, it is at a certain height h. Then what is potential energy? Potential energy will be mgh. So here also same thing here. What is the potential energy at this point C also? The potential energy is mgh. Now look at here. What is the total energy at a point A, at a point B, at a point C? Children, total energy, let us come from point B. At a point B, so we know the total energy means what? Sum of the kinetic and potential energy, that is 0 plus mgh will be mgh only. What about at point C? At a point C also the total energy is 0 plus mgh will be how much, dear children? Mgh only. Then what about at point A, dear children? Then what is the total energy? How can we calculate? Children, so very simple. When the bob is at a point B and C, it has only potential energy. So according to law of conservation of energy, for example, here it has 100 joules of energy. At this point also, it must have 100 joules of energy. But its form might be different. The name, whatever the name which we are giving, it might be different, dear children. But it is same only. Try to understand. The best example in geography we will be studying a river. So in different areas it may have different names, but the river is a common actually. The same way here, energy, dear children. Whether here at a point B or a point E, it might be different name, but the magnitude is same. Magnitude. We are talking about magnitude, dear children. Magnitude. So here, what is the magnitude of total heat? What energy? Mgh. Here, what is the energy? Mgh. So here also it is a mgh only. So at a point A also it will be mgh only. But here we may get one doubt. Sir, as we discussed that while it is crossing a point A, it has a maximum velocity, right? Then how can we calculate that maximum velocity? So children, before that, here this maximum velocity, let us say. So means what here? Look at here. Just assume a situation where the bob is coming like this. C to A it is coming. As C to A it is coming, at a point C, what is its total energy? Let us say due to the potential energy, it has only potential energy. Let us say it has only potential energy. Whereas at a point A, it has only kinetic energy. But according to law of conservation of energy, at a point A, kinetic energy equal to, at a point C, potential energy. Potential energy. Simple to children. The potential energy is getting converted into kinetic energy. So, the maximum kinetic energy at a point A is equal to the maximum potential energy at a point C. Is very, very important. So, what will be its kinetic energy at this point? Let us say, as Bob is crossing this point with a v velocity, let us assume, and its mass is m. Its mass is m. Then we know that it is half m v square. Half m v square. Potential energy is equal to how much? mgh. mgh. Now here children, m gets cancelled. So it will be v square is equal to 2gh. Children, as v square is equal to 2gh, v is equal to square root of 2gh. Children, so this is how, means this is a velocity with which a bob of a simple pendulum crosses point A, so that it has maximum kinetic energy. Children, a small logic here, Here at a point C and B, the name of the energy is potential. At a point A, name of the energy is kinetic. Just the name is different, the form is different. But if you can talk about the magnitude, for example, here 1000 joules of energy is there. Here 1000 joules of energy is there. Here also must be 1000 joules of energy according to law of conservation of energy. But the condition is that we are neglecting the air resistance. Children, when we neglect the air resistance only, mechanical energy is equal to the sum of the kinetic and potential energies. Children, so this is actually today's topic. What is a mechanical energy? How can we prove that mechanical energy, like a law of conservation of a mechanical energy for a freely falling body? And even we discussed about the graphical representation, means how can we represent the variation of kinetic energy and potential energy with the help of graph, which we discussed. And here is the application of law of conservation of energy. They discussed about a simple pendulum oscillation. In the next session, we will be solving the numericals based on this mechanical law of conservation of mechanical energy. Thank you so much, dear children. All the very best.